Good morning, children. Today we are going to discuss chemical bonding and molecular structure. And in this chapter, we will study about ionic versus covalent bonding, molecular orbitals and the covalent bonds, valence electron dot structures, octet versus non-octet, resonance structures, formal charges, PSEPR predicting shapes of the molecules, bond properties, polarity, bond order, bond strength. Chemical bonding, problems and questions. In this chapter we will discuss about how is a molecule or polyatomic ion held together, why are atoms distributed at strange angles, why are molecules not flat, can we predict the structure? How is the structure related to the chemical and physical properties? Forms of chemical bonds. There are two extreme forms of connecting or bonding atoms, or we can say they can combine in different ways. Ionic bond. Complete transfer of electrons from one atom to another. In this type of bond, usually we take the strong metal and non-metal, because metal has tendency to lose electron easily and non-metals have tendency to gain electrons easily. That is why generally or 99 or 100% this bond is formed between metallic and non-metallic elements. Covalent bond. Covalent bond is generally formed between the two non-metallic elements, that is in this that sharing of electrons will take place. Most bonds are somewhere in between. That is why we cannot say that the particular bond is 100% ionic or 100% covalent. In both the bonds, in ionic bond, some covalent character is present, while in covalent bond some ionic character is present. Ionic compounds. Ionic compounds are formed just like just now I have told you about this. This is essentially formed by complete transfer from an element of low ionization enthalpy, that is metal, to an element of high electron affinity, non-metal. In this the complete transfer of electrons will take place. Just like sodium, you can see easily sodium when react with Cl2 and then it will form NaCl. Right? Now this is primarily between metals and non-metals, just I mentioned earlier. Now see the structure of NaCl. Non-directional bonding via Coulomb charge interaction. Now another bond, that is covalent bond. Covalent bond is formed by sharing of electrons, means the electrons which are present in the valence shell, they are called valence electrons, and in this type of bond the transferring of electrons or sharing of electrons will take place, which are present in the outermost shell. Electrons are divided into core and valence electron. The electrons which are present in the innermost shell plus nucleus, that portion is known as kernel, and the outermost electrons present in the outer shell, they are known as valence electrons. Atom, core, valence. Just like this, you can see 3s1. 3s1 is the outermost shell, means one electron is present in the third shell and this electron is present in subshell S. Like this. We can make Lewis dot structure of sodium like this. And bromine. Bromine contains 7 electrons in its outermost shell, that is 2 electrons are present in S subshell and 5 electrons are present in P subshell. Total 7 electrons are present in the outermost shell. So it needs 1 electron to complete its octet. That is why the sodium will transfer 1 electron to bromine to form so that bromine can have the complete octet, as well as sodium will also have the complete octet by losing one electron. Like this. Now again Br. I am showing Lewis dot structure for Br2 molecule. And see the different atoms which are present in the first period and second period. They have the outermost electrons present with the red dots. Number of valence electrons equal to the number of group numbers. Now covalent bonding. The bond arises from the mutual attraction of two nuclei for the same electrons. That is, H1 means one atom of hydrogen contains one electron, another atom of hydrogen contains one electron. They both will share one electron and form H2 molecule. A covalent bond is a balance of attractive and repulsive forces. Now, this is the theory by which we can explain, this is the VBT, by which we can explain the formation of the molecule. Like this. Means same number of attractive and repulsive forces are present. See, attractive and repulsive. Attractive forces are shown with the yellow color arrow and they are 4 in number, while the repulsive forces are formed or shown with the help of red arrow. That is because attractive forces are more than the repulsive forces. That is why the molecule is stable. Now bond formation. In this there is a head-to-head overlapping between the atomic orbitals of neighboring atoms. That is why the bond is formed. You can ask why this atomic orbitals or how the bond is formed. So we can explain this with the help of atomic orbitals. When atomic orbitals of two different atoms overlap one over the other, then bond is formed, and that type of bond is known as sigma bond. In this, head-to-head overlapping will take place. Now see, hydrogen, the bonding is formed between the s orbital of hydrogen and p orbital of chlorine, because in chlorine p orbital is having 7 electron, and in hydrogen s atom is having 1 electron in s subshell. That is why S has the s orbital and p has the m means 5 electron. That is why there is a head-to-head overlapping between s and p orbital, s orbital of s and p orbital of chlorine. Now this type of bonding takes place in the electrons present in the molecular orbitals. They are present on the internuclear axis and form the sigma bond. Just like I have earlier also told you, the sigma bond is formed by the head-to-head overlapping, and the overlapping is up to large extent, and this is the strong bond. Now two atomic orbitals overlap to form sigma bond and molecular orbital, and they can be shown like this. And one more thing I want to tell you, see the place where the head-to-head overlapping will take place. At this place the molecule is present at the lowest energy level, and as the bond start breaking, then the energy level of the molecule will increase, because on breaking the energy is released, and when the bond is formed, energy is released, and for breaking we need more amount of energy. For breaking we need energy, that is why the amount of energy is increasing. You are seeing in the graph. Now see, two atomic orbitals overlap to form s molecular orbitals. Now molecular orbitals, you can ask question, what is molecular orbital? Molecular orbitals are the orbitals which are formed by the overlapping of same type of atomic orbitals. they have the same symmetry and same energy. And when two atomic orbitals having same energy, same symmetry combine together, they will form two types of molecular orbitals or two molecular orbitals. Among that, one is having low energy and lower energy than the atomic orbitals, and they are known as molecular orbitals, while the atomic orbitals combining together and forming the molecular orbitals of higher energy, they are called anti-bonding molecular orbitals. Now see p sigma bonded molecular orbital. What does it mean? P sigma bonded molecular orbitals means there will be overlapping of pp orbitals, and then head-to-head overlapping is taking place. That is why they are forming sigma bond. Now for example F2. In F2 molecule, both the p orbitals, they are joining with one another by the head-to-head overlapping. That is why single bond is present between two atoms of fluorine. See, this is the type of overlapping. Now electron distribution is depicted with the Lewis dot structure. Lewis dot structure is helpful in showing how the molecule is formed, because in that the sharing of electrons will take place in between the electrons present in the outermost shell. Electrons are distributed as shared or bond pairs and unshared or lone pairs. The electrons which are participating in the bond, they are called shared pair or bond pairs, and the electrons which are non-participating and present in group of two electrons, they are called lone pair of electrons. Now bond pair and lone pairs. Electrons are distributed as shared or bond pairs and unshared or lone pairs. Means we can divide electrons which are present in the outermost shell as the lone pair of lone pairs or bond pairs. Now see, here in hydrogen only one bond pair is there, while in Cl one bond pair and three lone pairs are present. See, one shared pair or bond pair and unshared or lone pair electrons are present. This is known as Lewis electron dot structure. Now how to predict the Lewis dot structure or how to form the Lewis dot structure? Now see, number of valence electrons of an atom equal to the group number. Now for groups 1a to 4a, lithium to carbon, number of bond pairs equal to group number. Now for group 5a to 7a, nitrogen to fluorine, number of bond pairs equal to 8 minus group number. Now except for hydrogen and atoms of third and higher periods, bond pairs plus lone pairs equal to 4. This observation is called the octet rule. Means we can say the outermost shell of each atom wants to complete its octet. Octet means 8 electrons should be present in the outermost shell, and if they are following this rule, we are saying they are fully satisfying the octet rule. But there are exceptional cases which do not follow the octet rule even though they form the stable molecules. For this thing we will discuss later. Now Lewis dot structure of ammonia. Now NH3. Now the formula of ammonia is NH3. Now central atom is nitrogen and the surrounding atoms are hydrogen. And how you will decide that the central atom should be nitrogen? Central atom is the lowest, should have the lowest affinity for the electrons. In ammonia, nitrogen is central atom. Now count valence electrons. Hydrogen has 1 electron while nitrogen has 5 electrons. Total electrons, that is 5, plus 3 into 1, that is equal to 8. Means 1 electron, 1 electron each hydrogen atom is having, and 5 electrons are present on the nitrogen atom. Because 3 hydrogen atoms are there, that is why 3 into 1 plus 5 electrons are present in nitrogen. That is, total number of electrons are 8 and they will form 4 pairs. Now building a Lewis dot structure, form a sigma bond between the central atom and surrounding atoms. At first we have to build the single bond, we have to form the single bond between the two atoms. And remaining electrons form lone pairs to complete the octet as needed. Now see how many electrons are used in making the shared pair. 6 electrons are used in making the 3 bond pairs. How many electrons are left which are not shared between these two atoms? That is 2 electrons, and that is why we can say nitrogen has 1 lone pair and 3 bond pairs. Now see, you can see 3 bond pairs are present while 3 shared pairs are present or bond pairs are present, and 1 lone pair is present on nitrogen. Now see, 3 bond pair and 1 lone pair. Now sulfite ion. Sulfite ion, sulfur, and it has 3 oxygen. Now count the valence electrons. Sulfur has 6 electrons, oxygen has 6 electrons. So total number of electrons will be 18 plus 6. It means, and 2 negative, 18 plus 6, that is 24, plus 2 negative charges are also present, that is why 26. Total number of electrons present in sulfite ion, 26. It means 13 pairs of bond pairs are present, or we can divide equally among bond pairs and shared pairs. Now step 3 forms sigma bonds. Now see, 3 sigma bonds are present between 3 oxygen and 1 sulfur. 10 pair of electrons are left because total number of electrons are 26 electrons. Now remaining pairs become lone pairs. First on the outside atoms and then on the central atom. Now divide equally these lone pairs of electrons. Now see, each oxygen atom is having 6 electrons present in the outermost shell, means which are left behind, which are not shared during the bonding, and sulfur is having 1 lone pair of electron. Each atom is surrounded by an octet of electrons. Now see, each atom is having 8 electrons in their outermost shell. Now see, oxygen 6 3 lone pairs are present and 1 bond pair. In sulfur 1 lone pair is present and 3 bond pairs. And in each oxygen you are seeing 3 lone pairs and 1 bond pairs are present. Now carbon dioxide. In the same way we can make structure of carbon dioxide. Carbon is having 6 electrons, means 6 electrons, total number. This leaves 6 pairs of electrons. Now place lone pairs on the outer atoms like this. In this way we can make carbon dioxide. Now see, carbon octet is not complete, means 1 electron is shared, and outermost shell oxygen, both the oxygen have the complete octet while carbon is not having the complete octet. That is why 1 lone pair of oxygen that is shared between the carbon. See, double bond is present between carbon and oxygen, so that each atom will have the complete octet. Because when we were making only single bond, the octet of oxygen was complete, but the octet of carbon was not complete. But when we make or when lone pair of each oxygen atom is converted into bond pair, then all the three atoms have the complete octet. Now the second bonding pair forms a pi bond. Now see, this is different. Now how this bond is formed between carbon and oxygen. See, double bond and even triple bonds are commonly observed in carbon, nitrogen, phosphorus, oxygen and sulfur. Why we are saying like this? Because these all elements are non-metallic elements and they have empty or incomplete p orbital. That is why the p orbitals are 3p orbitals. Among 3p orbitals, one will form the sigma bond while the other two will form pi bonds. That is why generally the p block elements will form pi bond, because they have the incomplete p orbitals. Now see SO3, now C2F4, sulfur dioxide. See, central atom sulfur, valence electron 18 electrons, right? And then 9 pairs of electrons. Sulfur, you can depict Lewis dot structure of sulfur dioxide like this. Form pi bond so that sulfur has an octet. Note that there are two ways of doing this. See, bring in left pair or bring in right pair, right? A better representation of sulfur dioxide is made by forming two double bonds like this. Each atom has octet, former charge 0. Former charge is the charge present on the particular atom in a molecule. So now former charge, children, former charge we will discuss later. Now thank you.